Hi coders, welcome to LeetCode. In this we will discuss LeetCode problem 3356 zero array transformation 2. So this problem is related to the previous problem 3355 zero array transformation 1. So if you not yet solve this problem, please solve this, and also I have added this explanation video in the description. You can also follow that also. Now in this problem, what the problem statement that you are given an integer array nums length n and a 2D array queries, where queries I contain three things: li, ri and value I. So each queries I represent the following action on nums. So decrement the value at each index in the range li, within the range li to ri in nums by at most value I. So you can choose it to 0 to maximum value I, correct? Within the range index that is in between li to ri. Okay, so the amount by which each value is decremented can be chosen independently for each index. So means that our range is suppose 1 2 3. So this 3 actually I can actually this index 3 index actually I can actually change. So maximum value I can actually choose actually 4. Suppose for index 1 I have to decrement by suppose 2. Next index 2 I actually choose 3. Index 3 actually I have choose 1. So they mention that the value can be actually different, but at most 4. Okay, they are trying to say that. Now a 0 is an array with all elements are equal to 0. So this is the same as the previous problem, but here actually what is the extra condition that previous problem, the problem 3355, there actually we can actually decrease the value by 1, but here actually we can actually choose value I, dynamic value, right, not constant. And here actually you have to do extra, they return the minimum possible non-negative value of k such that after processing the first k queries in sequence, nums becomes a 0 array. So we have to optimize this, right? We have to find the minimum value of k, that after k operation or k queries our nums array will be 0 array. If no such k exists, return -1. So this is the extra condition, like there actually we have to check in the previous problem what actually do, we have to do that after all queries we have to check that after all queries we have to check that our array is nums array is 0 array or not, correct? But here actually you have to check that after k queries we have to check that this array is actually 0 array or not. Now we have to find out that what is the minimum value of k, correct? So what actually you can do, so we actually k will run from 0 to k less than equal to queries, correct? For I can actually choose I have to find the minimum k. So k can be value can be 0 or maximum can go up to all queries, k less than equal to q, number of queries. So I'll check for each query, after each query I'll check that this array actually nums array or not, correct? So for in the previous problem what actually do, for I have done actually using the prefix sum, and then actually I check that this actually possible or not, actually possible or not. So here actually you can actually time schedule big of n, and for each query suppose there is no actually we will return -1 because there is no exist of any k. So that time we are running here actually big of q. So again the time schedule will be big of q into n, correct? Time schedule will be big of n square. So this will give us a TLE, brute force approach, clear? For each queries means I will actually start from k is equal to 0. Okay, I will assume that after I have to find the minimum value. So whenever I get any k, for actually this actually 0 array is possible, so that time I return true. Return true means I return the value of the k. If none of this is true, none of actually not get any 0 array, so ultimately you have to return -1. They mention that if there is no exist of k, that time return -1. So for this situation what I have to return -1, that time what I have to do, what I have done that I have for each queries I am running checking that that for each queries after k queries I can actually achieve actually 0 error or not. So for HB I am checking that 0 actually possible or not, that time should be big of n. So ultimate time schedule will be big of q into n. Okay, so that's why this will give the TLE. Now how can I actually optimize this? So this actually what is the thought actually you are getting for optimize to find the k? We have to use here actually binary search. Why? Because k will be suppose 0 to k actually maximum queries q, right? Q dot size. Okay, so all queries actually. So I will check if I use the binary search, this will be actually L and maximum R. So I will get a mid, so I will check that this mid, by using this mid I can actually is 0k actually 0 array is possible or not, correct? So this actually how little time is then, like this will be constant big of n to check that this actually 0 array is possible or not. But here the linear search what we are doing for k, that will be decreased to what, log q. It is clear. Then what will be ultimate times totally n into log q. The process is clear, the algorithm, the approach, how to actually optimize this. I am thinking that. So binary search is clear that our range, the binary for binary search, L pointer will be, left pointer will be 0 max initially, and right pointer will be maximum all queries I will use. So that's why the size will be L, R pointer will be q dot size. Okay, now for each mid I will check that is this 0 actually 0 is possible or not, 0 array possible or not. If it's possible, I will actually check that okay, this is actually the one possible answer will be mid, and I will try to check any better actually answer is possible or not. So that's why I will shift R is equal to mid minus 1, correct? So now go to the code, then it will be easy more. So I have to use the binary search. So L pointer will be 0, R pointer will be all queries I will to use, and answer will be minus 1. Suppose if there is no valid 0 is possible, so that time I will not modify this, so ultimately I have to return minus 1, correct? So that's why initial value will be minus 1. Now I am running this binary search here, this while loop. L less than equal to R, I will get one mid, so I will check that this mid, this is the current k. So this k actually I can actually achievable or not, 0 array is possible, achievable or not. So that's why I am passing the nums array and the queries and the first k. So I have to pass out that first k queries I have to use. So that's why I am passing this. If it is valid, return true. That means what? This is one possible answer. So I will modify this answer is equal to mid, and I will go to the better answer. So that's why I will shift the right pointer to mid minus 1. Better answer means what? I have to minimize the k value. So that's why I am shifting the right pointer to mid minus 1. Got it? L pointer I have to go to the next more queries, correct? So that's why I am using shifting the left pointer to mid plus 1. It is clear. Now this is the where actually I am checking this actually valid or not, 0 array is possible or not. So here actually what to actually get, I will get the nums array, queries, and the first k queries I have to use. So here actually what I have to use, prefix array, prefix sum I have already explained. But previous problem what I have to do, what actually maximum actually I can decrease, maximum value I can decrease by 1, but here actually I can decrease by value of I, right? This is actually dynamic. So that's why what I will do, here actually I will decrease by queries of I, 2 instead of 1. So you can check prefix of n plus 1, because I have to handle the where actually 0, 3, where 3 is the last index. So the effect of this particular queries will be gone at the index 4. So that's why index to handle this situation I added one extra index n plus 1. Now I am iterating the first k queries, I will 0, I less than k. Okay, first k queries. So this will be L pointer, this will give by L pointer, and this will be R plus 1. Okay, so our effect will start from index L. So queries I, 0, and the index prefix, that particular index I will start by subtracting the value of I. So this value I can actually maximum decrease, and this value will be on which index the effect of these queries will be gone, at a particular index R plus 1. So that's why queries of I, 1 plus 1, and the value I am adding just reversing, plus equal to queries of I, 2. Got it? So this is the things. Now I will do what? I will just do the actually prefix sum. So the current sum will be 0, and for each I am just adding the prefix sum into the current sum. What is the maximum actually I can actually decrease or increase, correct? So this will give the maximum what actually I can actually decrease. So I'll check. Suppose our current sum actually we can maximum decrease, suppose 10, and our nums I is equal to 20. So can I actually decrease this into 0? No, because 20 minus 10 I can actually achieve 10, not 0. So that's why I'll check if num size less than 0. That means what? This is 0, because that means what? I can actually decrease current sum is equal to suppose 100 and our num size is equal to 20. See, it will be always converted to 0. So that's why I'm checking if after subtracting 20 minus 100, it will be what? Minus 80. See, it will be always converted to 0. So that's why I'm checking if less than 0. So I will just ultimately convert to 0. Okay, just modify this. It is clear. And ultimately after doing this, I will check for each nums number in the nums array. If it is not 0, that means return false. This 0 array is not possible. Any of this element is not 0. And at the end, if it is all are actually 0, so at the end return true. Correct? So now it is, take the one example 4, 3, 2, 1. Same example, the previous and we can actually select index 1, 3 and value actually suppose 2. Okay, and next in this 0, 2 I can actually decrease by 1. Okay, so just go to take the prefix vector 0, 1, 2, 3, 4, because they are actually 0 to 3 and I have added one extra index because to handle the r+1 situation. So 1, 3, so our effect will start from 1, 3, so I can actually maximum decrease value 2 and the effect will run at index 4. Correct? And at the index 0, 2, 0 to 2, I will start minus 1. So here actually I can actually decrease by 1, and in the index 2 means index 3 our effect will run. Okay, so if I do the actual prefix sum, actually you can check actually here actually I can decrease minus 1, here actually I can decrease minus 1 plus minus 2, this will ultimately minus 3, here also minus 3, here actually 2, minus 2, and this will be actually 0. This index always give us the 0. Okay, this actually our, this 4 actually our effective value actually I can actually decrease. So our input array was 4, 3, 2, 1. So what is the value actually I can actually achieve? 3. Correct? Maximum value actually minimize this. So here actually I can actually achieve 0. Here actually I can actually achieve 0 because 2 is the nums input number, but we can actually decrease 3. So ultimately we can actually achieve 0. For 1 I can actually achieve minus 2, but we always convert to 0. So but here actually you can check this value actually not 0, 3, not 0. So that's why I have to return false here. All remaining elements are actually 0, but this element is not 0, so that's why I have to return false. Got it? It is clear how actually prefix sum actually helping us here. And also in the previous problem actually we have used the prefix sum. Here actually we have extra that we are using binary size, how actually find the minimum k. Got it? Any space complexity? Space complexity is that for each time to this each valid function, we are actually using a prefix vector. So that times to space complexity big of n+1 each time. Okay, any other things we are using any extra vector or not? No. So the space complexity big of n+1, big of n+1 times it will be big of q into log q into n. Correct? N for each valid function because we are iterating each element n, and for log q because we are using the binary search here. Got it? How I will automate this? If you like the explanation, if it is clear for you, please like the video. If you are not yet subscribed, please subscribe the channel. Thank you.